on to the last topic for this week's discussion, which is texture mapping and mipmaps. Okay, so first we need to understand how we apply textures to 3D objects. So normally we create our textures as these 2D objects that have texture coordinates, and the coordinates are typically called UV coordinates. And in order to apply this 2D texture to a 3D object, we need to define a mapping between the XYZ coordinates on our 3D object to our UV coordinates. Okay, and one typical problem that comes up when we are applying textures to objects is aliasing. So as you can see up here in the foreground of this scene, the texture looks completely fine. Since it's a lot closer to us, we are sampling this texture a lot more fine. And in the background of the scene, since it's so far away, we are sampling the texture a lot less than normal, and we get aliasing from this lower sampling rate for the texture. Okay, so we could deal with this aliasing with super sampling as we have before, but super sampling texture is quite slow. So what we do instead are use these mipmaps. So essentially what we do is we pre-compute our texture at different sizes, which also corresponds to having different max frequencies. So level 0 is the largest resolution texture that we have. Level 1 is lower resolution and therefore also has lower frequency, and we can continue having this resolution lower and lower until we get to this 1x1 texture. So what does this get us? Well, if we have a texture that's quite far away, as in this scene, then since we know our sampling rate will be much lower than normal, then we'll pick a corresponding texture level in this mipmap so that we won't have any aliasing for our texture. And this goes back to our Nyquist rate that we talked about earlier in this discussion. Okay, so we have computed all of these lower resolution textures, and we actually haven't increased the amount of memory that we are using by that much. We've only increased it by a third. So this image here kind of intuitively shows that if we have our normal resolution texture in these 3 boxes, half of the resolution will take up 3/4 of this box, and then we kind of continuously store it in smaller and smaller squares, and it's never going to be more than this amount of memory. So now that we know about mipmaps, how do we actually determine which level of the mipmap to use when sampling? So we need to do this by looking at the neighboring pixels. Let's consider this very close up part of the image. If we take our XY pixel here and we take a neighboring pixel and we translate both into texture space, the difference between these two UV coordinates will be quite small since we're sampling our texture very finely. And on the other hand, if we are sampling in this very far away part of our scene and we take our 2 neighboring XY pixels, and translate them into texture space, there will be a big jump between these two UV coordinates. So that's when we need to use much lower resolution textures. So if there's a big jump in texture space, then we want to use a higher level of the mipmap. We want to use a lower resolution texture. So now that we kind of understand this intuitively, we can mathematically compute this by doing the following. So we take our pixel, we map it to our UV coordinates, we take a neighboring pixel, x plus 1, y, and we map that into our UV coordinates. We take our neighboring pixel x, y plus 1, map it to our texture coordinates, and then we compute the difference between these UV coordinates. Okay, and then all we have to do is pass this into this equation here, and D will give us the level of the mipmap that we want to use. Okay, so what happens if D isn't an integer? Well, you have a couple options here. One of the ways to deal with this that'll give you a little bit higher resolution is to actually sample both mipmap levels. So say you have a D value of 2.5, you would sample mipmap level 2 and you would sample mipmap level 3, and then interpolate both of these values such that you kind of get a mix of both, and then use that value for your pixel.